Hey students, we're going to cover the else if statements AP classroom assignment. So let's get started. For one, I'm sure you've read this, and we have this message that says that the code does not work as intended, and we need to assume that the variable random number has been properly declared and initialized, and we need to determine which of the following initializations for random number will demonstrate that the code does not work as intended. So when we see these kind of questions, I say it is best that you just go like you use each value of random number and see what the code does. So what is key in this, if you read this, is that it sets the value to exactly one of the values. So it's not possible for event to take on two different values in the flow of the program. Well, aside from the initial setting of event equal to 0, but other than that, it can't be something different. It can't be event 1, event equals 1, and event then somehow equals 2. So we need to just go through the options and see which one flags. So if random number is 0.7, then 0.7 is, so we're going to start here. 0.7 is less than or equal to 0.7. So event will be set equal to 1. But then as you keep going through the code, 0.7 is also less than or equal to 0.8. So event would then get set equal to 2, and then the else doesn't trigger. So 0.7 triggers both if events. So for that reason, the code won't work as intended. So A is the one that we should choose because it says that if the probability is 70% or less, the event should be set to 1. So the value of event should be set to 1 if the probability is 70% or less. So the way the code is currently written, if you use the value of 0.7, you're going to get event equals 2. And so we don't need to really go through B, C, D, and E, but we will anyway. So for if random number was 0.8, then the first if statement, so we're going to say we're going to be using 0.8 right now. And so if 0.8 is the value, the first if statement doesn't trigger, and the second if statement does trigger, and therefore the else statement doesn't work. So 0.8 doesn't work. Same thing for 0.85. Well, not different for 0.85. So now if we're using 0.85, this if statement doesn't trigger because 0.85 isn't less than 0.7. The second if statement doesn't trigger because 0.85 is not less than or equal to 0.8. And so since the if statement doesn't, the second if statement does not trigger, that means the else statement does trigger. So 0.85 it works as intended, as is 0.8. And it's the same thing with 0.9 and 1.0. Both of those fail both ifs, and so then the else statement is what triggers. Now I should tell you that the else statement triggers to the closest if statement. It is linked to the closest if statement that is in the same code block as it. So this else statement only goes for this if statement. It has nothing to do with the first if statement. This first if statement is just a one-way statement, which means that if the condition is met, the code executes. If not, nothing else happens. So this is a one-way code block, that first if statement. So again, the first option was correct. For 2, we have 2 different code blocks. One is an if, an else if, and an else. And the second code block is a standalone if statement and an if statement with an else condition. And it says, assume that both code segments initialize choice to the same integer value. Which of the following best describes the conditions on the initial value of the variable choice that will cause the 2 code segments to produce different output? So again, to me, it's best if you just choose a value that fits each criteria. So for A, we need a value of choice less than 5. So let's go with choice equals 4, for instance. So if choice is, all right, so we're going to put the value of choice here so we can see what we're doing. So right now, choice equals 4. So for segment A, we're going to keep track of what happens. So if choice is 4, then 4 is not greater than 10. So the if statement doesn't happen. But then we have an else if statement. So now is choice less than 5? So 4 is less than 5. So what we get is red prints for A. And the else statement doesn't happen because the else if statement happened. Then for code segment B, again, 4 is not greater than 10. So the first if statement doesn't trigger. But 4, so the second if statement, choice being 4 is less than 5, red is printed, and so again the else statement isn't triggered. So A doesn't give us different outputs, so we have to eliminate that. And so then for B, we have a value of choice that's greater than or equal to 5 and is less than or equal to 10. So say we choose choice equals 6. So then now we have choice is 6. So now 6 is not greater than 10. So this if statement still does not trigger. You know what? Let's wipe it all out so we can see that we're doing something different. So if choice is 6, this if statement doesn't trigger. But now the else if 6 is not less than 5. So the else if does not trigger. So that means that our else condition of yellow, printing yellow is going to come up. So code segment A is going to produce yellow. And then if we do this with code segment B, choice is still 6. 6 is not greater than 10, so that if statement doesn't trigger. 6 is not less than 5, so the second if statement does not trigger. And so what's going to happen is that the else statement prints again, and we get yellow. So far we get the same output. So you would do this for each answer choice, and we're just going to, the correct answer to this is C. So fortunately, we actually get to that. Anyway, so any value greater than 10, let's go with choice equals 11, for instance. So if choice is 11, then what happens is 11 is greater than 10. So for code segment A, blue is going to print. Well, and then you don't do anything else. The else if condition isn't triggered because the if condition is met, and the else condition does not trigger because the if condition was also met. But then for code segment B, 11 is greater than 10, so blue is going to print. But then 11's not less than 5, so this else condition is going to trigger and print yellow. Now again, that's because this else statement is only linked to the if statement that is above it. So it has nothing to do with that first if statement. So the code that the value of choice that will produce something that's not intended is choice being greater than 10. So any value greater than 10. And you can go through and do the same thing with D and E. Well, E is just not true because we've already seen a difference. But then if you choose choice equals 5 or 10, you would see that those don't work. And also, choice equal 5 is going to be it's not the correct way to assign that because it's a double equal sign, and so that choice actually makes no sense. But even if you did choice equals 5 or choice equals 10, you still don't get the they still produce the same thing, which would be either it would be yellow in both instances. So number 3, we have a similar kind of problem where we have one code segment has an if, an else if, and a couple of else ifs and an else statement. And the second code segment has just a bunch of one-way if statements. So what's going to happen is that for the second statement, there's probably going to be a value that makes multiple if statements trigger. And so that's going to produce an error that we don't want. So if we go through our options, we're trying to, which of the following statements correctly compares the values printed by the two methods? So the code segment prints the same value only when the grade is below 80. So let's take a value less than 80, like 79. So if grade is 79, so grade equals 79. So 79 is not greater than 89, so that if statement doesn't trigger. The first else if statement doesn't trigger because 79 is not greater than 79. The second else if statement does trigger because 79 is greater than 69, and that means that we want to do points equals 2. So for the first code segment, we get points is equal to, well, we're going to add 2 to the point value and replace it. And that does fit because a grade of 70 to 79 should give us a 2.0. So then for code segment 2, the first if statement doesn't work because 79 is not greater than 89. The second if statement doesn't work because 79 is not greater than 79. The third if statement does work because 79 is greater than 69. So we also get points equals 2.0. So then the 79 is not less than 70, so that last if statement doesn't trigger. So we see that the code segments will print the same value when grade is below 70, below 80. So we know that's true, but we don't know if that's the only time they print the same value. So right now we're going to put a maybe by option A. For option B, when the code segments print the same value when the grade is 90 or above, or the grade is below 80. So if the grade is above 90, they're clearly not going to print the same thing. They're not going to store it's not going to print the same thing, because if grade is 90, so let's take this stuff out. So if grade is 90, what is going to happen for the first code segment is only 4.0 is going to be reported. Points is going to only have a value of 4.0. But for the second code segment, because we have a bunch of one-way if statements, 90 is going to work for this if statement, and that if statement. So you would actually get the value of points is going to be 9.0 after that code is executed, because 90 is greater than 89, 79, and 69. And so points isn't going to, so this statement isn't going to be true. So B doesn't work because it's not like though the first part of that statement is just not true. And so then for C, the two code segments print the same value when the grade is 90 or above. We've already seen that that is incorrect. For option D, both code segments print the same value for all possible values of grade. Again, we've seen that's not true with 90. And for option E, the two code segments print different values for all possible values of grade. And again, by examining option A, we've seen that's not true just using 79. All right. So by just process of elimination, we get that A is correct. And also just by seeing that we got the same value for 79. So option A is correct. Let's see. So for number 4, we have a condition where if x, the remainder when some integer is divided by 2 is equal to 1, we want to print yes. Otherwise, we're going to print no. So now the otherwise, when you divide by 2, you only get 2 remainders. You either get 1 or you get 0. So in this case, the else is implying that x, the remainder when x is divided by 2 is equal to 0, because that's the only other possibility. So obviously 1 works. So we're trying to choose which segments print the same as the original. So 1 works because the else condition is just basically saying if x mod 2 equals 1, print yes. That's exactly the same. But then if x mod 2 or x remainder 2 equals 0, print no. So this else condition is exactly the same as this if condition. So 1 clearly works. Now remember, there are only 2 possibilities when we divide by 2. You either get a remainder of 1 or you get a remainder of 0. So now that brings us to option 2. So this works. Else if x mod 2 equals 0, print no. That works. But then we have this else condition of print none. So remember, there are only 2 possibilities when we divide by 2. So this else condition never happens. Because no matter what integer you put in for x, it's either going to be an odd number, which is going to return a 1, or it's going to be an even number, which gets a remainder of 0. So this else statement never happens. So option 2 also prints the same thing as the original code segment. And then Boolean x mod 2 equals 0. So say you use x is, so if x is, so we're gonna say x is even. If x is even, then this Boolean value is going to be true. And so if this is true, we're going to print yes. Now up here, we want to print no when we have an even number. So 3 doesn't work because it prints in opposite order. So the only ones that we want are 1 and 2. So only D is correct. For number 5, we have x is 3, y is -1. And so then if x minus 2 is greater than y, we want to subtract y from x and then update x with that value. And then if y plus 3 is greater than or equal to the new value of x, y is equal to whatever y plus x is, and we store that as y. So here we have 3 minus 2, that's greater than -1. That's a true statement. So this if condition works. So now x is going to now equal 3 minus -1, which is 4. So x is 4. And so now we're going to get if, so y is still 3. So if -1 plus 3 is greater than or equal to, now remember x is 4 now because that if condition actually was met. So if 2 is greater than 4, which is not, y is equal to y plus whatever x is. So this doesn't happen actually. Does not happen. Does not happen. So what's going to print is x equals 4 and y equals -1. So D is going to be our correct answer. And that's just by us going straight through the code. For number 6, the following method is intended to return true if and only if the parameter val is a multiple of 4, but is not a multiple of 100 unless it is also a multiple of 400. The method does not always work as it does not always work correctly. So which of the following method calls will return an incorrect response? So we can take out D and E immediately because neither of those are actually divisible by 4. So the code is going to work as intended because the first condition won't trigger, and then it's going to return whatever these two things are divided by 400. And 2001 divided by 400 doesn't have a remainder of 0, and 2010 divided by 400 doesn't have a remainder of 0. So we're going to get false in both of those instances. Remember, this is a Boolean expression. So whatever you get here, you're checking to see if it equals 0. If it equals 0, that's going to be true. If it's not 0, you're going to get false. So again, D and E are immediately out because of the else condition failing. So else condition fails. So then we look at option C maybe. So if the leap year is 2000. So 2000 is going to be a leap year because the remainder when you divide by 4 is 0. And it's also a multiple of 400. So 200, not a problem. 1984, we should get true if and only if the parameter is a multiple of 4, but not a multiple of 100 unless it's also a multiple of 400. So 1984 is not, it's divisible by 4, but it's not divisible by 100. And it's also not a multiple of 400. So 1984 also works. So just again, by process of elimination, we get A being 1900 as the correct answer because, so what happens with 1900 is 1900 divided by 4, that's going to get you a remainder of 0, but 1900 is divisible by 100, but is not a multiple of 400. So what's going to happen is 1900 would make this true when it should jump down here. So basically, this if statement is missing a check for divisibility by 100 and 400. So that's the reason for 1900 not working as intended. Number 7, which of the following code segments will assign the correct string to grade for a given integer score? So in one and 2 have a bunch of one-way if statements, and 3 has an if and a else if chain all the way down. So like say you choose a grade, like we'll say grade equals what's something that's gonna make one of these blow up? So let's do a grade of 91, I think will work for this. So if 91, no, let's go with 90. Hold on. So let's see. So let's start with option 3. So whatever we choose for option 3 is going to so if we start with option 3, like say we choose a grade of so if the grade is greater than or equal to 93, report an A. Else, if the grade is greater than or equal to 84, choose a B. Else, choose a C. And then, else if the grade is greater than 75, choose a C, or put an F. So 3 is going to work as intended from 75 to 83 inclusive. Is going to be a C. So 3 works, we know for sure. And then, so option 2 doesn't work just because the syntax is incorrect. So 1 and 2 are the exact same thing, except they're saying the same thing, except that 2 again doesn't is not typed correctly. You can't do a compound inequality like this in programming. So 2 doesn't work and 1 works. These if conditions, like this if condition matches the else if condition down here. So if like a grade of we'll say a 90. So 90 is greater than or equal to 84 and is less than or equal to 92. So that's going to get you a grade of B. And then the same thing for a value between 75 and 83. That's going to get you a C. So again, 2 doesn't work because it's just syntactically incorrect. Logically speaking, it's correct in terms of how you're thinking about it, but coded, it is not correct. So only 1 and 3 work. Number 8, we have this method where we have public int pick, and we have a parameter for a Boolean value and 2 parameters for integers. And so we're doing this method pick, and then the parameters are false, pick true 0, 1, and pick true 6, 7. So this method still works because we still have 2 ints as those last 2 parameters. So pick true 0, so pick and true 0, 1, that's going to return. So if true, you're going to return X. So this is going to spit out the second parameter, which is 0. Then pick true 6, 7. Excuse me. So pick true 6, 7 is going to spit out a 6, because if true, return the X coordinate, which is the second parameter, else return the Y, which is the last parameter. So what we're actually evaluating is pick false 0 and 6. And if the if condition doesn't trigger here, so we're going to return the Y, which is the last parameter. So you should get 6. You should get 6. Number 9, a school does not have, you can read all of that. So if degrees is greater than 95, print the school be closed due to extreme heat, else print school is open. Which of the following will demonstrate that the code does not work as intended? So if the temperature reaches or exceeds 95, so greater than or equal to 95, school is going to be closed. So if that, when the temperature is 95, the code does not work as intended, because since 95 isn't greater than 95, this if condition won't happen, and so it's going to print school is open. But again, based on how this is worded, you should print school will be closed. So C is the correct answer. For number 10, X equals 7. If X is less than 7, what's the result of this code segment? So X is 7. So this first if condition is not met because 7 is not less than 7. So this doesn't happen. So none of that code block happens. But then we have a second if statement that again is a standalone statement. 7, the remainder of 7 when divided by 3 is 1. So you're going to add 7 to, you're going to add 2 to X. So now in this line, we know X is equal to 9, and then we're going to print 3 times X. So you should get 3 times 9, which is 27. And the last problem is we have a double regular price Boolean on clearance. Boolean has coupon. And if on clearance, you're going to do final price is minus the final price times 0.25. And if you have a coupon, you're going to take $5 off, what's printed as a result of the executing the code segment. So the product is on clearance. So it's on clearance and we don't have a coupon. So on clearance, no coupon. So the final price is going to be 100 minus 100 times 0.25, and you replace regular price with final price with that. So final price. So that means that 75 is stored in final price right now. Because the clearance thing is triggered. but the has coupon is not triggered, so we're printing the final price. That's going to be 75.0. I'm sorry, yeah, that should be 75.0 because we multiply by a double. So that concludes this if statements video.